Good afternoon, students. Today we have to start onwards question number 5 of your exercise 6.4. So, question number 5 I am reading. D, E and F respectively are the midpoints of sides AB, BC and CA of triangle ABC. So, this is the triangle ABC given to you. D is the midpoint of AB. E is the midpoint of BC and F is the midpoint of AC. This is given to you, AB, BC and CA. Find the ratio to find the ratio of the area of triangle DEF. That is, if I join these three midpoints, one triangle will be there in your picture, to that of whole of this triangle area, that is area of triangle ABC, I need to determine. So if you remember, last year you did the same question somewhere in the application part of your midpoint theorem. Once again we are back to same. If you think that you can proceed in the same way what you did in class 9th, most welcome, you can do that. But now the question is given in your topic of similarity, so how we can go for that? So let us see here in your proof. If you see that D and F are the midpoints, line joining the two midpoint is always parallel to the third side, that is by basic proportionality theorem, because D comma F are the midpoints. Midpoints means dividing this AB and AC, that is AD upon DB is equal to AF upon FC is equal to 1 upon 2. That is 1 upon 1, half of, if AD will be equal to DB, AF will be equal to FC. So this upon this will be equal to this upon this. So therefore DF will be parallel to BC. Also you can say that DF is half of BC. Why? See, because if you count this AD upon AB now, so don't you think that will be equal to 1 upon 2? Because now I am speaking about the whole ratios term point of view, that is this upon whole of this only I can put is equal to this upon whole of this. So AD upon AB will be equal to 1 by 2. So AD upon AB I can write is equal to DF upon BC also. This upon whole of this only can be equal to this upon this. So that is equal to 1 by 2. So therefore your DF upon BC will be equal to what? 1 by 2. So DF will be equal to half of BC. Means we are back to the result of our midpoint theorem. This side is parallel to the third side as well as half of the third side. So last year we said that somewhere D, B, E, F is a parallelogram. If you want to proceed in that way, most welcome. Diagonal divides the parallelogram into two congruent triangles. Similarly, another parallelogram you will be getting. There are three parallelograms. D, B, E, F is 1, D, E, C, F 2 and D, E, F, A 3. So in three parallelograms you are getting these four triangles are lying there, and all four triangles are equal in area because diagonal of the parallelogram divides the parallelogram into equal two triangles. So in that way you can prove all these four triangles congruent to each other. But if I am applying the basic proportionality theorem here, then what happens? Now you see, you are saying that DF upon BC is equal to 1 by 2. So similarly, don't you think that I can prove that DE will be equal to what? So DE upon AC will also be equal to 1 upon 2, and your EF upon AB will also be equal to what? 1 upon 2. Now you see that DF, DE and EF somewhere are the sides of this triangle DEF, and then the whole triangle we are getting somewhere is, that is your ABC. So ABC. Now we are getting DF upon BC. DF upon BC is equal to DE upon AC is equal to EF upon AB. So EF upon AB means the three corresponding sides of one triangle are equal to the another triangle in proportion, because everywhere the proportionality I am getting is equal to 1 by 2, 1 by 2 and 1 by 2. So hence I can conclude that these two triangles are similar to each other. So if these two triangles are similar to each other, then their area will always be equal to what? Any pair you can choose, that will be equal to DF square upon BC square, or in whole you can say DF upon BC whole square. So what is DF upon BC is 1 upon 2. You can pick any of the pair out of these everywhere, because that is equal to 1 upon 2. So DF upon BC you are writing 1 upon 2 whole square means that is equal to 1/4. So therefore area of triangle DEF will be equal to 1 by 4 of the area of triangle ABC, or the ratio of these two will be equal to always 1/4. So we did last year as per the application part of your midpoint theorem. This year if you want to proceed in this way, their proportionality is same, so you can conclude by using your area theorem here. That's why the question is added to the part of your application of area theorem. So here is the solution. In both the ways you are most welcome to go for the same. So let us move to question number 6 now. Question 6 of 6.4 is, prove that the ratio of the area of two similar triangles is equal to square of the ratio of their corresponding medians. So okay, this is ABC. Suppose this is DEF. If AL is the median here and DM is the median here, so these two triangles are given similar. Given triangle ABC is similar to triangle what? DEF. To prove area of triangle this ABC to that of area of triangle DEF is equal to AL square upon DM square. Very important result, not difficult to prove at all, because we did the same thing in our previous exercise questions also. So in my proof, I know ki if I am looking for the square of AL and DM, somewhere I need to check the similarity of this ALB as well as this DME. Now already I am given with AB upon DE. AB upon DE is equal to what? BC upon EF. BC upon EF, because triangle ABC is given similar to triangle DEF, and once the triangles are similar, then their corresponding sides are in proportion. So here I am looking for BL, and I know that BL is half of BC. Similarly EM, so EM again is half of EF. Why? Because L and M are the midpoints, as AL and DM are the medians. So again I will take half as per my own requirement. I will go for that. So here it is. So you can see that half of BC easily I can write is BL, and half of EF again I can write is EM. So now AB upon DE, AB upon DE I am getting is equal to BL upon EM. So therefore AB upon DE is equal to what? AL upon DM. This upon this I have proved is equal to, BL upon EM. BL upon EM. This upon this, and this angle also is equal to this angle. Why this angle is equal to this angle? Again triangle ABC is similar to triangle DEF. So and angle ABL is equal to angle DEM. because ABC will be equal to DEF. So BL and C and EMF are collinear. So I can take ABL because I'm sharing the similarity of triangle ALB and DME. So ABL will be equal to DEM. So this upon this now is equal to this upon this, and this angle is equal to this angle. So these triangles are similar by SAS. So if I have proved now these two triangles, that is your ABL and DEM are similar, so by SAS, so then the area of these two triangles will be equal to ratio of the square of their corresponding sides. And you can see here AL and DM now are the sides, so I can easily write area of ABL upon area of DEM is equal to AB square upon DE square is equal to BL square upon EM square and AL square upon DM square. So area of two similar triangles can be equal to what? AL square upon DM square also, because if this was equal to AB square upon DE square, somewhere was given equal to BC square upon EF square. So here I have taken half. So if I'll take the twice of BL, that will be equal to BC square and EF square again. So in that way I can prove that area of triangle ABC to that of area of triangle DEF will be equal to what? AL square upon DM square, because AB upon DE is also equal to BC upon EF as well AC upon DE. So here you have proved is AL square upon DM square. So no doubt should be there in proving. Similarly, you can apply the same to the altitudes also. Altitudes also will be in square as well as the angle bisectors. If AL and DM are the angle bisectors of A and D, again this result will be true. If AL and DM are the altitudes, so again this result will be true. Because in that case, so it is very easy. If B will be equal to E and L will be equal to M, so this triangle again is equal to similar. And if these are the bisectors, so angle A will be equal to angle D. Whole angles are equal as these two triangles are similar, so half of those angles will also be equal. So then again triangle ABL similar to triangle DEM. So somewhere we have to focus our attention towards the similarity of these two triangles. Once we have proved, then AB square upon DE square easily we can write is equal to AL square upon DM square, whether that is a median, whether that is an altitude, or whether that is an angle bisector given to you of any of the vertex angle. So in that way you can apply this for all three cases, medians, altitudes as well as of your angle bisectors. So that's all about question number 6. Let us go to question number 7 then. In question number 7, prove that the area of equilateral triangle described on one side of a square equal to half the area of equilateral triangle described on one of its diagonal. Very interesting question. Again you see here we are given with a square ABCD. Suppose I am taking the side is X and the diagonal is also there. Now one equilateral triangle is described on one of its sides. Suppose I am taking this is your DEC. So if this is X, this is also X and this is also X. Another triangle is described on its diagonal. So I am taking this is the another triangle. Suppose I am taking this is AFC. So AFC is another triangle which is described on its diagonal, because I need to check the relationship of these areas, that is of DEC and of AFC. So now here AC is equal to under root 2x. Am I clear to you? That is, remember always, diagonal of the square is always equal to under root 2 into side. Under root 2 into side. So side is X here. So diagonal will be under root 2. As the triangles are equilateral, so if this is under root 2x, so this will also be under root 2x and this side also will be under root 2x. So now what is to prove? I have to prove The triangle described, prove that the area of an equilateral triangle described on one side of square is equal to, that is area of triangle DEC is equal to half area of triangle ACF, that is described on its diagonal. So in my proof, do you think that triangle DEC is now similar to triangle ACF? Why? Angle criterion, because both triangles, because both are equilateral. Both are equilateral. This is given to you. Both are equilateral means 60 degrees will be there. So as these triangles are similar, so then area of triangle DEC to that of area of triangle your ACF, any side can I pick? DC square upon AC square. Can I say DC square upon AC square? Once the triangles are similar, then the ratio of their area is always equal to ratio of the square of their corresponding sides. And everywhere the ratio will remain same. So finally I can write this is DC upon AC what? Whole square. DC upon AC whole square. Now what is DC upon AC? So these values, DC is equal to what? X, and what is AC is equal to under root 2x. So when you will be taking the square of this, so what happens? So your DC upon AC will be equal to x square upon 2x square, because square of x is x square, square of under root 2 is equal to 2, and square of x again, so x you can cut here 1, so this will be equal to 1 upon 2. So now this ratio you are getting is equal to 1 upon 2. So area of DEC to that of area of ACF will be equal to 1 upon 2. So if you cross multiply, so area of DEC, that is the triangle described on one of the side, is equal to half the area of ACF. So ACF is the triangle which is described on its diagonal, hence proved. So finally you cross multiply this. So area of DEC will be equal to half the area of ACF, which we need to prove. So that is the end of your question number 7. Then come to question number 8. Question 8 is ABC and BDE. Suppose any triangle ABC we are talking, and anywhere D point on BC I have taken, and another triangle BDE is there. These are the equilateral triangles given to you. D is the midpoint. BD is half of BC. So BD upon BC is equal to 1 upon 2 given. What you need to determine is ratio of the area of triangle ABC to that of area of triangle BDE. So now you again see, as these triangles, triangle ABC again is similar to triangle BDE. Why? Angle criterion, because again both are the equilateral triangle. These are the equilateral triangles. So similar, so therefore the ratio of their area will be equal to what? BD square upon BC square. So BD, I need to take BC first because it is ABC to that of your BDE. So BC square upon BD square. So that is BC upon BD whole square. What is BC upon BD? Take the reciprocal of this, 2 upon 1 square. So answer will be your 4:1. So area, their ratio of the area of ABC to that of BD will be equal to 4:1. And question number 9, all of you can do comfortably. MCQ type question again. Sides of two similar triangles are in the ratio 4:9. You need to determine the areas of these triangles are in the ratio. So if the triangles are similar and the ratio of their sides is 4:9, so their area will be 4 square upon 9 square, that is 16 to that of 81. I hope that is clear to you all. So that is the end of your exercise 6.4. Tomorrow I will start with the proof of your Pythagoras and its converse, and then the application part. So, and one assignment related to your this area theorem, plus few more questions I will add to your assignment from criterions point of view. So 5-6 question for assignment and with proof of your Pythagoras and its converse we will do tomorrow. Thank you.